Hi everyone, so this is the code for task 3, that is Boston house price prediction. First of all, I've imported all the necessary libraries, and then I've also imported the dataset from Sklearn.datasets. And after importing the dataset, I've loaded it and then converted it into dataframe. And then for observing our dataset, I've used head function. And then for getting the shape of the dataset, I've used the dot shape. It will give us it actually giving us 506 by 14. That means the dataset has 506 rows and 14 columns. Then I've used some data analysis techniques. For that, first of all, I've checked whether the dataset contains any missing value or not. And as you can see, it doesn't contain any missing value. And after that, I've used the describe function for getting the summary statistics. It will basically give us the mean, maximum, minimum standard deviation of each and every column. And then I've used some data visualization techniques as well. For that, I've used displot function. It basically gives the distribution plot of our target variable as well as our feature variables. This distribution plot basically helps us in determining whether there is any outlier or not. And then after this plot, I've also used scatter plot function. It will basically tell us whether there is any linear or non-linear relationship between our feature variable and target variable. And after that, in the end, I've used correlation matrix. It will tell us basically whether each of this feature variable, that is crime rate or all of these variables, whether these contains any significance in predicting our target variable or not. And as you can see from the last column, none of this value is 0. That means to some extent each of this feature variable is important in predicting our target variable. So I've used the original dataset and did not drop any column. After that, I've split the dataset into testing and training. And then I've created 3 models and then trained them. First of all, I've created the linear regression model and then trained our dataset, then random forest, and then XGBoost. After training, I've used predict function for getting the predicted values on testing dataset. After getting the predicted values from each model, we will then evaluate each and every model on some performance metrics. For that, I've used mean squared error, mean absolute error, R-square score, and adjusted R-square score. These are the metrics value for linear regression. As you can see, the mean square score is quite high, and the R-square score is not that good. These are the values for random forest. The mean square error is relatively less compared to the linear regression, and R-square score is quite good. And for XGBoost, we have these values. It gives the best values of these metrics, as it gives the least value for mean square error and for mean absolute error, and the highest value for R-square score. So it can be concluded that out of all the 3 models, the best model for this task is XGBoost. So yeah, thank you.